Alrighty, thank you very much, Stanton, for being here and helping with this project. I'd like to introduce Stanton Gill. He's an extension specialist in IPM and entomology for nurseries and greenhouses, and a professor in Montgomery College. And he works through University of Maryland in College Park. I was lucky enough to work with Stanton when I was a student and an employee at the University of Maryland. And I just want to thank him again for being here to help us with this project. So Stanton, take it away.
All right, good. Well, we're going to be talking about scales for a second time this morning. And I thought we'd start with just talking about bugs in general here. And this is not a scale, obviously, but this is what most people think bugs should look like. They've got antenna, they've got legs, they've got a mouth part you can see. This is a brown marmorated stink bug that's being carried off by these two little soldiers here. But scale insect are a whole different class in the bug world. To many people, they don't really look like insects on most of their life stages. They have protective covers that make them blend in with bark, and they tend to go unnoticed by most nurserymen and landscapers. There are over 8,000 different described species and 7 different families. They were originally classified in an order called Homoptera that I grew up in for years knowing as, but that was switched about 10, 12 years ago to an order called Hemiptera and suborder Steinerankia. And of course, the family, subfamily Cosidae. All right. What you're looking at right here are soft scale. These are the tulip tree scale, and this is on a magnolia. And you can see where they're swelling up, and you'll see an ant in the center. And what's going on is this group of scale insects are what we call soft scale in a family called Cosidae. And what they do is they tap into the phloem on the plant, and they will pull out the plant juices. They're after really the protein out of that, but they'll pick up water and sugar. And just like a diabetic has to pass sugar, these insects are passing the sugar off, and that drops out as honeydew. Ants will show up, and they will actually protect these scale insects. So they're not your buddy in this case, because to them, they're something to harvest the honeydew from. So if you see ants crawling up on a plant and they're hanging around a cluster like this, it's probably a soft scale that you're looking at that are producing copious amounts of honeydew. The females usually are flattened on the branches during the wintertime because they're overwintering in a what's called a second instar stage, very unnoticeable. But when they begin to swell up with eggs, they enlarge themselves, and they look like almost an army helmet as they enlarge like this. And at that point, they're feeding very, very heavily and excreting great amounts of honeydew. Okay, so some basics on scale insect. You look at this branch in here, and you can see something's wrong with it, but you're not real clear exactly what is that. And to most people, it doesn't look like an insect. It could be part of the plant. Many people misdiagnose that as a disease. That happens to be on a dogwood right there. And what you're looking at is an armored scale called the Japanese maple scale, which is one of the nastiest of the nasties that we see in the nursery industry and in the landscapes now. Scale insects, whether it's a soft scale, an armored scale, or a felted scale, all of these produce a covering that covers their body, that protects them. All right. On a armored scale, the cover that is going all over the body is not really attached to the insect. And one of the field techniques I teach landscapers and arborists all the time and nurserymen is take a probe needle with you. And if you go to what you think is a cover of a scale and use your magnifier and flip that over, pop the cover off it. If it comes completely free of the insect and the body of the insect is left behind, then you're likely dealing with an armored scale. On soft scale, it's a different setup. The wax is actually incorporated into the body. So when you flip them over, the cover is not going to come free of it. It's hooked onto that body. All right? And that's going to be true with the felted scales also. And the big major families that we worry about on scale, I mentioned in the beginning, there were 7 different families, but the armored scale are the most numerous ones we see in the nursery and landscape. And that's under a family called Diospitidae. The soft scale are the next most numerous ones we see in the landscape, and that's under the family Cosidae. And finally, we have the felted scale, which are pseudo-Cosidae. And those have become very popular, especially on things like the crepe myrtles. Okay. Now, all these soft scales, the name of the game with them is blend in. They really are excellent at camouflaging themselves, so it makes it very difficult to discern them, that they're different from that plant you're looking at. So if you look at each of these, you see the top one, those females, they're humping up. Well, you can see that, okay, at that stage. But that's only when they're laying eggs inside there. But if you move back in that stem, you'll see some things more oval shape, tannish color. That's the overwintering form on that. That's a second instar stage. And that's rather difficult to pick up. If you move down to the center one here with the clustering of grayish color, elongated things, that's the Japanese maple scale. And you can see how that easily could be missed by people who think that's part of the plant. It really does look like it blends in. Finally, this one on the left is a one called minute cypress scale. And we see this on Leyland cypress very commonly. We'll see it on some junipers. We are now picking it up on some of the arborvitaes too. That tends to be small. If you look at that first instar cover, which is in the center, looks like a little nipple out of the center. That's the first instar cover. The second one is that yellowish color, and then kind of a clearish color down below is the last instar. But again, very difficult to pick up with the naked eye. So it slips by a lot of people that are involved with the plant propagation and growing on of plants and actually installing them in the landscape. So scales get transferred from place to place quite accidentally because people just aren't recognizing them. Here's a close-up of a female armored scale. And this one is, should be the green peach scale. And, or I'm sorry, white pernicula scale. I got that one. All right. So on the cover, what you're looking at is that thing in the center, that kind of brownish cover, is when the insect hatched out and went to what we call crawler stage. They have antenna, they have legs, and they move around usually for about 12 to 24 hours. And they have to find a place to settle down. They put their mouth part into the plant and begin to pull up plant juices. They have pores all over their back, which I'll show you in a minute. And those pores, those micropores, will produce wax, and that covers the body. When it goes to this settled stage, we call it a sessile insect, all right? So it's not moving anymore. The cover going over that is that first little brown thing you see in the center. It looks like a little nipple, all right? Now, when the insect goes to the next life stage, it has to shed its skin and enlarge itself, since it has an exoskeleton. Well, if it's going to get larger, that original cover is too small. Just like you, if you're too big for your apartment, now you got to move into a townhouse or move into a house, get bigger. So what it will do is excrete more wax out of its back and create a new cover and pushes up that first cover. So the first instar cover is now on top, and I get the second instar down below that. That bottom one you see, but the third ring out, that is the third instar cover, all right? And that's when the female has reached her mature stage. Once she has mated and then she's going to lay eggs, she will then excrete that thin little layer around the edge on this one, and it's called a crawler flap. And underneath that is where, when those eggs hatch, the new crawlers come out, they go exit through that flap, okay? Now, if you pop that cover off that we just looked at, this is what the insect looks like if you looked with, this would be magnified about 5 times. It just looks like a yellow blob. It's difficult to tell which end is the head and which end is the rear end on this insect. And I'm sorry I said it was white pernicula scale. That was actually San Jose scale we're looking at. They're both armored scale, look very similar. If you look at the top of the picture, the orangish brown part is called the pygidium, and that's the rear end of the insect. The head part is actually down on the other end, the bottom part of that. But again, looking with your naked eye, you're not going to pick that up, and it really doesn't look like an insect to most people at this stage. Now, what we do in coccidology is we will puncture this thing with a pin, and then we pump out the fluids. Then we put it in a solution of KOH. to clear all the body fluids out of there, the hemolymph and everything else that's in there. And then we'll put a stain in there, and we stain that, and then you can begin to see body parts. And I'm going to show you a picture of what they look like if you had stained it and looked underneath the microscope. What you're looking at, it says dorsal and ventral view. Ventral, of course, is the bottom view. Dorsal is the top view. If you looked at that insect after it had been cleared and put underneath the scope, on the ventral view, you can see it has 6 legs, which is on any insect. And you see it has antenna. You can see a little anal opening in the center of that. And then where the divided line is, that's showing the top view of it, or dorsal view of the insect. All those little dots you're looking at, where it has little dots coming out, showing the circles, those are showing you macro and micro pores, okay? And they're different sized pores, and that's what excretes the wax and that covers their body and coats the insect. Yeah. So scale insect research involves digging deeper and deeper all the time, and you do have to look under the scope to see things. Now, one of the ones I mentioned to you and showed you a picture of is the Japanese maple scale. This one was introduced quite a length of time ago, back in the 1890s. And when Americans didn't travel around that much, it was mainly by stagecoach, horses, or railroads. It wasn't as big a deal. But when the automobiles moved in, people started moving more. This thing has grown to be a greater problem. Now that much of the nursery stock is grown vegetatively, not necessarily rooted cutting, but sometimes they're grafting things onto understocks. Sometimes that wood has the scale on it and it gets transferred over. Again, because they blend in, people don't notice this insect. So it has risen in the last 10 years to be a major, major problem in nurseries in the, I'd say from the Midwest to the East Coast here, as one of the big, big armored scales that we have to deal with. Now, you see several names here beside my name. You have Brian Kunkel, who's with the University of Delaware, Paula Shrewsbury, who's at the University of Maryland, Nancy Harding is her technician. And we had different people. I had my technician on there, Suzanne Click, and some extension educators involved. We set up some projects to look at this scale because it has risen up as such a major, major thing in the nursery industry. We started back in 2003 doing our work with it. And it turns out that no one had really done up the life cycle on this insect. Now, whenever you're going to go after any insect, whether it's scale or any creature there, you need to understand its life cycle. So we spent the first couple of years establishing how many generations this had per year, when did those occur, and then also what plant material it fed on. Now, the bad news is it has I mentioned, or I didn't mention this one yet, crawler period on most armored scale is usually about 10 days to 2 weeks. This insect is the exception to the rule. Crawler periods on that first generation can be 6 to 7 weeks long. The second generation, it can be 7 to 8 weeks long. So it's a very long time for the crawlers coming out, and the crawlers will disseminate themselves, spread themselves through the wind or carried on plant material. So it makes it very difficult to control. The second thing we found is it feeds on a wide, wide range of plant material. So it can impact many of your plants out in your nursery, both evergreen and deciduous plant material, and end up in the landscape. Now, this scale insect, if you look at this plant, and you see the lenticels on the plant, the woody part, but see the white part there, those are the female covers right there. Now, if you look into one just about in the top center, there's white with a little bit of brown there. That white wax on the outside is a light covering. If you brush it with your hand, you'll see it looks more of kind of an amber brown color. Now, if you look at it on the right, you'll see a red maple, I'm sorry, a Zelkova. Should have been a red maple, Zelkova there, that is coated with that scale. But if you're standing back and looking at it, you can see a little bit of that white, but you may not pick up that there's really a problem going on in that tree. That is actually a very heavy population of the Japanese maple scale on that plant. The Zelkova is one of the things we commonly found that on. The other thing is red maples and dogwoods. Very big on those, but it hits such a wide range of plant material, it's incredible. Here you can see a map of places that the scale has been found so far. It's been mainly East Coast. Interest in West Virginia has been skipped. I'm not real clear why. Maybe they just haven't detected it. But you can see your area in North Carolina is definitely in the red as far as having this. It's basically on the whole East Coast. It has been slowly spreading in the Midwest. Indiana was added on here about 10 years ago. It was not there before. It's just a matter of time until it moves its way into Illinois is there. So it has a wide spread at this point, and it will continue to expand, I suspect. Here's a list of some of the plants that we found in Maryland that are very susceptible to this insect. And you can see it's very large, and we keep expanding that. In 1996, Miller and Davison, which are two coccidologists, one with USDA and the other with University of Maryland, they had listed 13 families and 16 genera. In 2018, we had increased that in our findings in Maryland up to 27 families, right, and 47 genera. So we more than doubled our numbers here on what is hitting. So over 300 different species of plants can be hit by this. So this is a very serious pest. You want to be very observant if you're a nurseryman to make sure you don't introduce this into your nursery. We've had some Maryland nurseries we've had to work with very closely, and it usually takes us at least 2 years once this thing is established to bring that under control, and that's with aggressive treatments being made. Here are a red maple, and they are very susceptible to that. You look at that and you say, well, okay, it doesn't look like I have a problem. But if you move in close, you'll find the scale. Generally, you'll find it where those branches are coming hooked onto the main trunk. And that's where they'll start. Again, they can be relatively low numbers to start with. The females are going to birth out between 100 to 300 young out of each female. And they are going to move out in different parts of the plant, settle down. There will be a loss rate from drying out and predation and everything. But even with that, you're going to build the population very rapidly. And you'll begin to see the dieback on that plant, not in a year or so, but it will take a couple years. It's a slow dieback. If you move up close, then you can begin to see those scales, that one we were just looking at there. You move up close, you see these now. These are magnified. This is 8 magnification here. So you begin to pick up that there's actually scale in there. If your eyes trained, you'd know that was Japanese maple scale, but at least you could tell it was a armored scale on there for most people. We did a survey that was done in 2019, and we were surveying nursery owners. We did 16 nurseries that we surveyed, and 27 arborists. And we asked them to rank different scale insects as what were the most problematic. And the Japanese maple scale won hands down on both with nurserymen and landscapers. On the picture on the left there, you can see where the covers are building up. They usually are on these branches where they come in, where it'll start. They tend to cluster together when the population is just starting to build on there. But once it really gets going, you'll have them coating up and down the stem. The picture on the right shows you a cover that is flipped over. And what you're looking at is a pregnant female. On this scale, when her eggs are developing inside, her body goes from originally it would be a tannish color to start with. As the eggs develop, she's going to turn kind of a purplish color. So very distinct. The crawlers that come out of here are very large, and they also have a slight purplish color to them when they go into the crawler stage. At the University of Maryland, we did a lot of work on this, and we did some work in Delaware also with Brian Kunkel on this, on the Japanese maple scale. And we've developed the life cycle, the crawler activity, degree day, plant phenology on this. If you want to go to our web page called IPM.net, and then put Maryland next after that, you'll come to the web page, and then we have a fact sheet that we've put on there on this scale insect, since it is one of the major ones, with all the life cycle information and the information about degree day, so it can help you deal with it. And it will also talk about the control options on this. So here's what we found on it. The females, of course, will lay an egg. You have the first instar stage, which is a crawler, which will move around. And then the next stage of that is the crawler. It's still in the first instar, where it settles down within 12 to 24 hours, puts a wax coating over its back. Then you have a second and third instar, and the third instar is the adult sexual mature stage. The males will egg first instar, second, third. They have a prepupal stage, pupal stage, and then comes out a winged adult. The adult that comes out there is very small, gnat-like. They have one pair of wings, much like dipterous insects, but they're not in that order. They're in the order Hemiptera, kind of an anomaly. If you looked at them very closely and look down the tip of their leg, they would have one tarsal claw. That's a little bit unusual for insects. Most of the other insect species have 2 or 3 tarsal claws on there. Not so with these males. There are 2 generations per year. The way they're overwintering right now is second instar stage. Both male and female are on the stems. As it warms up, they're going to mature into the first, the female go to the third instar, and then the male will continue on to the 5th. Compared to a lot of other armored scale, they're pretty late in the season. They're not one of our early ones we see. It's usually late spring, early summer before we begin to see the crawler period on those. When they come out, they have a very long crawler period, and it's going to be at least 7 weeks, sometimes 8 weeks, depending on which generation. And a lot of times they'll overlap each other. They are dispersed by the wind in this crawler stage. They're very light-bodied. They don't have wings, but they're easily carried by breezes. If you're working in the field in a nursery, and it's difficult not to be working out there, you can pick it up on your equipment. Your workers can pick it up in their clothing and transfer it from plant to plant. So you need to be conscious of this. Again, what makes this one so tough is that such a long crawler period. That's a long time to disperse the population and build up on plant material. Here's a good stage you can see right here where we've rubbed off some of the white wax, and you can see those females. Now this population is definitely in an out of control stage here if you're getting this sort of build up on stem. One thing we found is with nursemen, one of the big problems, of course, is deer rubbing in a nursery, and they've used guards on the trunks of the trees. If you have a solid type guard, plastic guard or whatever it is, you will find the scale insect will actually build up underneath that because they're free of all the parasitoids that would take them down. So what we suggested in nurseries, we realize you have to protect against deer, use a wire mesh protective wire around the trunk. So it will prevent the deer from rubbing, but also the parasitoids can, and the predators can find the scale insect to try and reduce the population. Right? When you're monitoring down the field, I look in these crotches of the branches is one of the common places to see them building up first when they're just starting out. And then later they could be on any of those branches around the trunk when you've got this out of control stage here. Again, many times the cover have that white, slight wax cover to them. If you rub that, that easily comes off and they'll turn that amber brown color. Okay. So what you want to do is monitor for crawlers well, when the degree day model is showing this time. One of the things in scale insects is they're very susceptible to most pesticides if applied during a crawler period. Now, one thing I'd precaution you is when scales are producing crawlers, that is when most of the predators and parasites are also active. And these are our good guys. We want to keep them around because they help reduce population. So in a sense, they're working for us. We want to take them out with broad spectrum pesticides. I would not use some of the older classes of organophosphate, carbamates, or pyrethroids for this stage. If you're going to go after a crawler stage, you'd want to use insect growth regulators, commonly called IGRs. There are 2 presently on the market that I've done extensive work with. One is Distance, D-I-S-T-A-N-C-E. The other is Talus, T-A-L-U-S. Both of these, what they do is when the insect goes from one life stage to another, it inhibits the formation of their exoskeleton. So they can't successfully move on to the next life stage. We've used it in nurseries, and we've done it at our research center in trials on several of the armored scale, especially on this Japanese maple scale, and found it to be very effective. But again, what I mentioned earlier, if you get it into a nursery and you build up a population, we've worked with nurseries where they let it go and then asked us to work with them. It usually takes us at least 2 years, and we have to hit it in both crawler periods with that talus or the distance repeatedly. But you can bring it under control if you do an aggressive spray program. It's just difficult to let it go to that stage. Now, if you want to keep this scale and other armored scale in relatively low populations, one of the most inexpensive things to be using is a horticultural oil. Generally, we suggest that in Maryland, our growers use that in November, December, after plants have gone dormant. And they can use between a 2 and 4% rate on the horticultural oil. The next time you can do it is in the springtime, usually March, April, when the temperatures are 50 to 55 for at least 4 or 5 days. The reason you want that temperature up is the oil is a suffocant. Insect respiration is tied into the ambient air temperature. So if it's colder, the oil isn't on there long enough for it, evaporates off and it's gone, and you don't get a great suffocation. If the respiration is up on the insect, the oil doesn't have to be on there as long to suffocate them. That works on low populations of scales, keeps them suppressed. It's very difficult to make that work once a population has reached these high levels. So you're going to have to go to the insect growth regulators in most cases for that. Okay. Now, here's the deer protection I was mentioning earlier with the solid plastic guard. We removed it from this part here on the left, and we moved it down so you could see it. But the scales tend to build up underneath that protection. They like that secluded area. And then here you can see on rough parts of the bark is where they're going to tend to build up at first. So for early detection. Now, beside degree days, you can use plant phenology indicators to tell you when they're going to the crawler period. If you look at things like Syringa chinensis, the Chinese lilac, and actually that's not a picture of it there, that's another lilac. When it comes into full bloom, that's when the first generation is occurring. If you have Stewardia pseudocamellia, when that's in bloom, then they're going to crawlers. If you have the native Catinus, smoke tree, that's another thing. When it's in full bloom, then you usually have crawler period occurring. For the second generation, it gets a little more difficult because there aren't as many plants in bloom at that time. But if you had Aurelia spinosa someplace by, you could see the blooms, that's in full bloom. Seven sun plant, Heptacodium, that's become very popular in the nursery industry and now in the landscape. When that thing's in bloom, then that's the start of the second generation crawler period that we're going to see on those. I mentioned earlier on this scale, the crawler that comes out is kind of a pinkish purple color. It's very large. It's one of the larger crawlers that I've seen, rather colorful. They're very active. They only have 12 to 24 hours to move around, and they're running on body fats at that point. If they don't settle down and tap into a plant, they will die. So they have to settle. Then they will excrete that wax to cover their back, and then they become that sessile stage we talked about earlier. Okay, here is two pictures you're looking at. On the left is a male. That is in the fourth instar stage, where it's getting ready to pupate. You can actually see the eye spots and a little bit of the antenna developing on that upper part of the body. If you look on the one on the right, that's a third instar female, and that one is not gravid. She's not pregnant. When they are impregnated and the eggs develop, her body will turn a little more like that color you're seeing on that male, kind of a pinkish purple color. But before they're impregnated, they're going to be this kind of tannish brown color. You can see the eggs being developed when we flip a cover over there. The eggs are rather large on that. They're purple. And I mentioned earlier, they have a very long crawler period, and that's what makes this thing so difficult, or spread so much and so difficult to deal with. Here's one of the charts that we've created over the years, and we've done several years of this to establish when the crawler periods are occurring on here. If you look at those peaks, that one year we had a peak in 1,085 degree days is when they were active, and that's pretty late in the season if you look at it that I wouldn't always use those dates because that does vary from year to year on how warm and how early it was in the spring. Degree days are pretty much a constant. That second degree day you see is closer to 3,000 degree days is when they reach a peak activity. Now, if you're going to spray with an insect growth regulator, I wouldn't do it when they just start. I would do it when it's reaching just about the peak on each of those cycles to be most effective with it, okay? Sometimes we get a little mini peaks out there, and what's happening with that is the weather, and that's some of the overlapping we're seeing with that first generation, and it's carrying almost into that second one. So weather influences the insects. Here you can see another year where we got activity that started a little bit earlier in the year. We had a little mini peak at 5/12. Again, you wouldn't use calendar dates, use degree days. And see, this degree day is a little bit different from that first one, 1,203. The other one's 3,139. So we have to do this over several years and then average out to come up with degree days to tell you when it's going to be about the peak activity you're going to see on these crawlers. That's how it's established. We had to do that for each of the different insects. Right? Again, you get that overlapping right here. This is one of the degree day calendars that we put on our website, on that IPM Net Maryland website. And we have when this crawler period start at around 816 degree days, peak around 1,100, and it's about 8 weeks activity. The second one starts around 2,500 degree days and peaks at around 3,000 degree days. So it's about 7 weeks in that second one. All right. So from there, Brian Kunkel, who's with the University of Delaware, and I cooperated, and we had several people involved, my technician, Suzanne Click, and Heather Zindash, and some of the extension educators like Chuck Schuster and Jenny Rosenkrantz involved. We set up trials at nurseries to evaluate some of the newer controls that come on the market. I mentioned to you distance and talus, using that to crawler stage. We've done many years of work with that, and that's effective. But now there's new systemics that have come onto the market that look like they have potential. So we set up trials in 2017, and we were dealing with the nursery, and these are American hollies that were grown at this nursery. Now, I mentioned this scale hits a wide range of things. You can see it on deciduous plant material, but you can see it on hollies. One of the problems in hollies in the nursery is that many times people shear them to look like Christmas trees. It may look lovely to everybody to sell. The thing is that tightens up the foliage so much that it makes it very difficult when a nurseryman tries to spray in there and make contact with an insect. So we were looking at these systemics to see, can we make that work better in these tight situations like this? So data was collected after we did applications on these. We did it at different dates. We did it July 14th. July 26th, and then we came all the way back in September to see how these things are holding up. These are some of the materials. The talus I mentioned earlier, the growth regulator, we know worked, so that was our standard to say, let's have that in there. The newer material was this Altus. That is from Bear Company. It's a new systemic they brought on the market in 2017, and it's listed as both a foliar spray and a soil drench. So we looked at both ways on that. And then dinotefron is one of the neonicotinoids that's sold under the name Safari, and Transtech is another name for it. And we looked at spray and foliar on that. Would that work on these tight hollies? Okay. Treatments were made June 21st of 2017. The hollies that we were dealing with were around 6 to 7 foot high, otherwise about 2 meters. They had all been sheared, very tight, and completely randomized blocks we used for this. And these show the treatment rates that we used for this trial. Here you can see the hollies. They've got a distance between them. We always would make sure there's at least 1 or 2 plants in between that were untreated in our trials. And that's it. They were color-coded with a marking tape, and then we would put in wood stakes next to them with a color code so we could keep them straight with all these different treatments. And there were untreated controls in here too, so we can have this as our comparison. Now, interesting. I try to make this chart exciting by putting stars in here, because often you look at those things and you go, well, oh my goodness, what are they trying to show us here? Well, here's the interesting part. All right, if you look at that, we did a count where we came in 2 weeks afterwards. It isn't shown on here because we really didn't see any difference between the control and any of the treatments at that date. That was 2 weeks afterwards. We came back in July 26th and did another count. That was about 4 weeks after the treatment. If you look at the blue line there, okay, that's the control, and that's what you want to compare it to. The one black treatment is Altus foliar. Really wasn't any significant. There was no significant difference between that and the control, nor was there one with the Altus where we did the drench on the one. Now, the other ones, they were starting to show a little bit where they show stars over them. Those were significantly different, but it was taking a month before we saw any level of control in there. Now, if you look at that next one, we went into September, okay, which was full past 2 months past the treatment date. And if you look at that, you can see on the controls, the numbers are significantly higher. And you look at all the treatments, the Altus fared very well. The Safari, both foliar and drench, did very well for us. So we do have viable options. But what the point I wanted to make on this is that you need to give it time. Do not expect something to be, dead within a week or two after you treat it. You'll get some impact maybe a month later, but it's going to take a little bit before you're going to see that insect actually die with these systemic materials. Okay, so that's basically it. Now, the fact sheets I mentioned to you, we do have these on the website, and you can download these PDFs if it helps you out on the Japanese maple scale, and this is on our website of IPM.net. All right. Now, here we go. So now we've been through the basics on the armored scale. We're going to look at a hedge of Leyland cypress, and this is very common through all the East Coast. Everybody's been using Leyland cypress in the South, right up to the Philadelphia area in Pennsylvania. Wonderful screening material. The plant was extremely popular in the 70s, 80s, and 90s. Now it's starting to die down because of all the different disease problems associated with it, but it's still found in landscapes. Now, if you look at that, you'd say a hedge that was blocking out of view, which obviously someone's trying to do, but you begin to pick up a little bit of off color on this far left. It looks almost like it's like overexposed or something, but actually that's the beginning of a scale problem, all right? Now, if you move in close and look at this with some magnification, you can actually see there is something on those needles. You may not be quite sure what it is, but there's something on there different that's foreign and shouldn't be there. If you take a needle probe and probe on that, you'll find that the covers come free and you can have the body remain. And so it was an armored scale from that. Soft scales, if you tried to probe that off, the cover is built into the body so it wouldn't be removed. So we know we got some sort of armored scale on there. All right. If you move a little bit closer and look at that, what you'd find is this thing was loaded with a armored scale called the minute cypress scale. All right. Now, keep in mind, Leyland cypress are usually propagated vegetatively. So a nursery may have a stock plant and they take cuttings off there. If it ever gets a scale like this, it may not be this heavy, but it could be a light population, and they take cuttings off that and put it into a mist system. They're now rooting a cutting with a population on it. It can easily go unnoticed in low numbers. And then it's grown on to a nursery, and it might grow there 2 or 3 years. And someone may, again, not notice it. It's not excreting honeydew and creating problems with sooty mold, so something you could pick up on. You really got to visually see the insect on there. Now, when it's moved into the landscape, there it's going to continue to build up and result in a dieback. And the problem is, if you look at a big hedge like we were just looking at there, it's going to be very difficult to spray that and obtain control. So really, control needs to happen back in the nursery and in the propagation stage. You need to be aware, you're looking for scales like this. What I would suggest is if you're propagating evergreen plant material, make up a tank, like a watering trough or feeding or watering horses or cattle. And you can take Suffix oil. They've got it on their label for drenches, for dunking, I should say, rather than drench. And you can take the cuttings and dip that in an oil solution before you go into propagation. And that will help knock down low populations of scales. It's not going to wipe everything out, but it will hopefully knock the numbers down that they're at acceptable levels. Okay. The minute cypress scale, and one looks very similar to this, is called the juniper scale. It's another armored scale. Um, we see it on junipers and we see it on Leyland cypress. The crawlers appear at 320-degree days and are active just to 500-degree days. That's a much shorter time than that Japanese maple scale we just looked at. So you got a smaller window to deal with. The material that I mentioned earlier, talus and distance, are very effective on this scale if you can get in that crawler period. The talus and distance has minimal impact on the beneficials that would be feeding on those crawler stages. So there's a good approach to go with for controlling that. If you look closely here, you'll see the blue arrow aiming toward a male cover, okay, that's more elongated. And then the blue top one says female cover, is more rounded shape. On an armored scale, a lot of times the females are round or oval shape. The males in the first early stages may be oval shape, but then they'll also develop this wax felted sac they put out of their end, and it's called a carne. And that's where they'll go through that prepupal and pupal stage and then eventually emerge out as an adult. Right? Now that white carne cover is what's going to catch your customer's eye, and probably anybody doing monitoring. That's the first thing they're going to notice. Now, if you look at that plant and stand back from the ground, you're not looking at that solid brown tissue. That's something else going on there. That might be a little bit of ceridium, canker, or dieback. But if you look above that, you see that off color where it looks like it's highlighted. That is a building up of a population on the minute cypress scale right there. Looking from the ground, it's difficult to pick that up. You need some sort of pruning shears to prune that off, bring it down, and take a close look at it, and you'll see something like you see on your right part of the screen here. Okay. The charts have been made up. You can look at dates. The problem with dates is that each year does vary. We can have early warm springs where you accumulate degree days very quickly. So it may not be May, June. It may be some years April they start activity. Or it can be later if it's a rainy year like it was in 2018 and push that date back. Degree days are much more accurate for figuring out when crawler periods are occurring. I would suggest checking with North Carolina State Extension with their specialist and also with the extension educators out in the counties and see if they've worked out degree days for the scale in your area. So rather than just go by calendar dates. Now, arborvitae is become a big plant for replacing the Leyland cypress. People want a fast-growing, screening plant material, and I understand the desire here. The problem again is this plant is grown vegetatively, so cuttings are taken and rooted under a mist system, and you can have the scale population on the plant and go unnoticed. Now you look at this picture, you can see those raised up helmet type things. Okay, now that you can pick up with your eye. Those are females that are swelling with eggs. Those are noticeable. But if you look in the center left of that, you'll see two small light brown color things. Those are second instar overwintering forms of that scale. That's much more difficult to pick up. And that's usually what slips by people when they're propagating these things, or they're growing on in a nursery. This scale will build up on that plant, and this is a soft scale. So this one will produce honeydew. And then when you get the honeydew on the foliage, if you have a wet period, you're going to see sooty mold growing there. You'll see that black sooty covering the needles. Okay, that one's called Fletcher scale. That is on this arborvitae. We see this you can see on Leylands also, but several, and cryptomerias even can be picked up on there. But you see the females, when they're swollen up, they're quite noticeable, all right? When they're in the overwintering second instar stage, much more difficult to detect, all right? Another scale that we see on the plants is Fletcher scale. And there you can see crawlers moving around. And you can see the little antenna and legs on there, the kind of the light color things. And you see the female where they're swollen up, right? They can be very small, overwintering second instars. They're difficult to see. When they get large like that, they're very noticeable. On this thing, you can find it beside the arborvitae, you'll find it on taxus, you'll find it on junipers, okay? Only the females overwinter And the eggs are usually in sometime in Maryland, it's around late May. But again, you need to check with your extension specialist or educators out in the field, see when the degree days are for figuring out on the crawler period on this thing. Most of the systemics I found on evergreens, generally if you do as a drench, not as effective on getting up the trunk and getting to where these will work. As a foliar spray, we have used some of the systemics and been effective on that. The talus and distance I mentioned earlier are very effective on this, controlling this scale. Okay, so the distance or talus, here's the names up here for you written on there. Certainly the oils are always a good idea to have in the mix. They're relatively inexpensive. They're very effective when populations are low. When they're really high, the oils not as good as you would like, but keeping them suppressed, yeah. Systemics on the evergreens, for right now, I'd have to say I haven't found anything other than foliar spray to be really effective. All right, thank you very much for listening, and I hope my role helps you suffering the pains your plants suffer. And thank you very much for listening.